Hello, my name is Dr. Bugase, and I'm going to demonstrate for you the Newton's law or air trap experiment. The experimental setup is based on the second law of Newton, which is used to determine uniformly accelerated motion. So we can determine the distance traveled as a function of time, the velocity as a function of time, the acceleration as a function of the accelerating mass, and the acceleration as a function of force. The experimental setup consists basically of an air blower, a tube that connects the air blower to its air rail. On the air rail, we have a start system which allows us to start a glider. A glider has 10 centimeters screen on it, and on the glider also we have hooks that allows us to put on weights symmetrically on the glider. Towards the end of the air rail, we have a fork system that stops the glider when it is running down, and at the end of the rail we have a precision pulley, and on that precision pulley we have a weight holder attached to a massless rope of about 200 centimeters, which is tied to the glider and hung on the precision pulley. Most importantly, we have 4 light barriers connected to a 4-digit timer, which allows us to measure the time taken for the glider to pass through these light barriers. So, for example, we have also masses that allows us to change the force of acting on the glider by placing different masses on the mass holder or on the glider symmetrically. The distance traveled as a function of time, for example, we need to place our timer at the S function, and then we place our light barriers at equal distances apart along the rail. There is calibration on the rail that allows us to do this precisely. To demonstrate this, you put on your air blower and increase the pressure of the blower, and then we start our glider using the start system, and then we record from the timer. So we do this, and then we start. So here, the various timers measure the time it takes for the glider to pass these light barriers. And so, we can repeat these measurements for several times, take an average, and then we determine the distance traveled as a function of time. We can also incorporate the masses at the various ends of the glider and the light weight holder to do the other experiments. Thank you.